Hello and welcome to my YouTube channel. In this video, I am going to explain how to draw shear force and bending moment diagram of such type of beam. Okay, as you can see, we have a beam with 2-point loads acting downwards. These point loads are trying to bend our beam, but at the same time, our beam is symmetrical. So first of all, we will calculate reactions, then shear force diagram, then bending moment diagram. Okay, so first of all, we will calculate a reaction. Total we have 3 steps to solve this problem. Okay, reaction will be RA is equal to RD is equal to total load acting on the beam divided by 2. So the total load is 15 plus 15 is equal to 30 divided by 2. So we will have 15 kilonewton on each support end. Okay, so will be 15 kilonewton upward and also 15 kilonewton upward. So 15 kilonewton at RA, which is reaction at RA, and 15 kilonewton reaction at RD. So 30 kilonewton coming downwards and 30 kilonewton going upwards. So it means our beam is stable. Okay. Now we have to calculate, we have to draw a shear force diagram on base of these numbers. So this is our beam line representation at point A and at point B. So this is going to be A, this is, we have B, this is C, and at the end we have point D. Okay, as you can see, we have 15 kilonewton at point A. This is the value of point A. So it means our shear force diagram line will go upwards 15 kilonewton. So this is just a roughly, I have drawn the line. Then since we have point load, the line will be straight to the second point. And then when it comes to point B, 15 kilonewton acting downward, so it will come down to point B. When it comes to point B, we don't have any load, so again our line will be straight to point C. Once you are at point C, then again we have 15 kilonewton acting downward, so the line will go 15 kilonewton down and then again straight to point D. So this is our negative part and this is our positive part. So always positive is in upside of the line and negative is downside of the line. Okay, so this is our shear force diagram for this beam. So this is step 2, shear force diagram. Okay, now we have to calculate or draw bending moment diagram. Before drawing any bending moment diagram, there are 2 methods to calculate or draw a bending moment diagram. So I will explain both of them one by one. First of all, I want to calculate the values on our beam so we can draw our bending moment diagram on base of these values, the one which I am going to calculate now. Okay, so how do we calculate bending moment values? So these are bending moment values. So I would say this is step 3, bending moment diagram. Okay, so first of all, we have to calculate the values. It is understood that in bending moment diagram, our first and last end should be 0. So how we can do that? Let me prove it by calculating the values. So okay, I will say bending moment at point A is equal to 15 multiplied by 0. Why 0? Because we don't have any values. So whatever value, whatever force is on any point, it will circulate around that point. So it will be circulating. It means that we don't have any R to multiply with. So it will be 0 kilonewton at point A. So if our 0 kilonewton comes at point D, it means our diagram is correct. Okay, let's move on to point bending moment at point B. So how we can calculate it? Now we have value which is 15 To get to point V is 1 meter. So 15 multiplied by 1. Okay. You are now at point B. So it will be 15 kilonewton. Now bending moment at point C. How it would be? Your force is at point A. So keep in mind, when you calculate bending moment values, you have to consider all the force while all the distance. For example, along the beam. Okay. 15 multiplied by the distance till C is 2. Okay. Then minus 15 kilonewton acting downwards at point B. So it will be 15 multiplied by 1 minus 15, because downwards, so that's why it's minus. At point C, we have nothing, no R, no distance to multiply, so that's why we don't write it. So it will be 30 minus 15 is equal to 15 kilonewton at point C. Now bending moment at point D. So if the values of our bending moment at point D comes as 0, it means our diagram and our calculation is correct. Let's find out. Okay, so start from the beginning, as we started from the beginning, from point A till point D, step by step. So 15 is at point A, this is our force. To get to D, the distance is 3 meters. Then minus 15 kilonewton. So this part is finished. We have calculated, is here. Now at this point, 15 multiplied by 2 minus, because acting downwards. Then again minus this 15, the second 15. 15 multiplied by 1 again. So what it would be? This is 45 minus 30 minus 15. So what will be the answer? 45 minus 45 is equal to 0. So at point D and at point A, our values are 0. So it means our calculation is correct. Now we have to calculate a value. We have to draw a bending moment diagram. Before drawing a bending moment diagram, let me explain the second method of calculating the values for bending moment. Okay, so I will just draw a line. I will say this is first method. Now the second method of calculating bending moment values on each point. Okay, so second method, how to calculate that? We will calculate bending moment at point B, and how it would be, as you can see, bending moment formula is, let me write a formula first. So the formula for bending moment is force multiplied by distance. Now at point B, as you can see, at point A we don't have any distance. Once we get to point B, we will have distance of 1 meter. So bending moment will be at point B, not on point A. Point B will be the force is 15. To get to point B, the distance is 1 meter. So it will be 15 kilonewton. Again, B to C, we just have a distance, but we don't have any force. Once we get to point C, we have a force acting downward, which is minus 15. Okay, so it will be 15 multiplied by 1. The distance to get to point D is 1. So again, it will be 15 kilonewton. So this is a short way of calculating bending moment values at any point. Okay, now we have two values at point B and at point C. Both are 15 kilonewton. Now we can draw a bending moment diagram by using these values. Okay, so it's simple. This is not something complicated. This is a line which is representing our beam. So it's point A, point B, point C, that's point D. point of concern are our B and C, because all the loads are acting in the middle of the beam, not in the middle, in the beam, and these are making issues. These four loads can make issue for our beam. Now we have values at point B is 15, point C is 15 as well. So this is a roughly guess that I would consider this is a 15. So it will be 15 here, 15 here. Now we have to just connect these lines, these points with each other. So this is our bending moment diagram for the above beam. I hope you understood, and if you still don't understand anything, please don't forget to write in a comment box and I will try to explain it again. That's it for today. Thank you for watching my video. Please don't forget to subscribe my channel.